Just one glance at the countless formations in the firmament shows the dimensions of the universe far exceed our imagination. When we consider that our view of the stars covers only a tiny fraction of the entire universe, it becomes clear that we are still far from having unlocked all the secrets of our galactic neighborhood. In addition to the exploration of already known celestial bodies, the search for previously undiscovered planets is one of the most important fields of modern space research. The main focus of scientific interest is on those objects that are most similar to our Earth in terms of their composition. The search for potentially habitable planets has kept the scientific community on tenterhooks for several decades. A recent discovery by NASA leads now to the fact that the list of Earth-similar celestial bodies has been supplemented by a further unusual representative, TOI 1231b. While planets in our immediate galactic neighborhood have been known to us for many decades, beyond our solar system, there are still countless celestial bodies whose existence we know nothing about. Until recently, these included the exoplanet TOI 1231b, which made scientific headlines due to its unusual atmosphere. NASA employees at the Jet Propulsion Laboratory in the U.S. state of New Mexico were responsible for the discovery of this celestial body. The experts succeeded in locating the fascinating object at a distance of about 90 light-years in the night sky. The exoplanet orbits a red dwarf, one of the smallest stellar representatives in the universe. Scientists quickly realized that the newly discovered planet has some striking similarities to our terrestrial home. The celestial body needs only 24 days to orbit its host star once. Regarding its average surface temperatures, TOI 1231b can be confidently classified as Earth-similar. The average surface temperature is 134 degrees Fahrenheit, making it one of the coolest known exoplanets. Comparable transit planets show, in most cases, scorching hot surface temperatures exceeding several hundred or even thousands of degrees. Experts also assume that there are clouds in the atmosphere of the planet. According to initial findings, the object's natural protective shell is composed of hydrogen. At the same time, the research results give an indication that the surface of the celestial body could be adorned by liquid water. While these early findings give rise to sensational conjectures, future investigations are needed to fully fathom the nature and precise characteristics of the fascinating exoplanet. Kepler 452b. When it comes to the question of Earth-like celestial bodies, there is no way around Kepler 452b. The planet owes its name to the Kepler Space Telescope, which helped to identify the object. The host star that Kepler 452b orbits is located about 1,800 light-years from our Sun. In fact, the two gleaming bright celestial bodies show fascinating parallels. The remote star is only 10% larger than our Sun. The exoplanet itself, however, easily dwarfs our Earth in terms of its dimensions. According to current estimates, the diameter of the exoplanet is up to 80% larger than the diameter of the Earth. To circle its central galactic fixed point once, Kepler 452b needs about 385 days. Since the celestial body is located in the habitable zone of its planetary system, it's considered a promising candidate for the hypothetical existence of extraterrestrial life forms. TRAPPIST-1d. About 4 years ago, renowned scientists made a sensational announcement: the discovery of the TRAPPIST-1 planetary system. According to their findings, at least 7 Earth-like exoplanets orbit the red dwarf that gives the system its name. The experts came to this conclusion when they noticed that the brightness of the low-mass celestial body decreases at regular intervals. This observation indicated that several objects must repeatedly pass in front of TRAPPIST-1. Of all the known celestial bodies in the TRAPPIST-1 system, the planet TRAPPIST-1d is one of the most exciting. In all likelihood, the object 40 light-years away from us is a rocky exoplanet that lies in the habitable zone of its galactic association. TRAPPIST-1d needs just over 4 days to complete one orbit of its central star. Regarding its size, the exoplanet appears to be somewhat smaller than our Earth. It's probable that TRAPPIST-1d, like all other representatives of this planetary system, is tidally locked. This means one side of the celestial body is always illuminated by light, while the opposite side remains in permanent darkness. Evidence suggests that a vast ocean of liquid water may have once existed on TRAPPIST-1d. However, most of this water is thought to have evaporated over millennia. Nevertheless, it is possible that at least a small portion of the water has defied the ravages of time and remains on the planet. However, nothing is yet known about the exact chemical composition or the hypothetical atmosphere of this celestial body. Proxima b. When we travel 4.2 light-years into space from our Earth, we encounter the star Proxima Centauri. Located in the constellation Centaurus, this red dwarf is the closest star to our Sun. However, observing this fascinating object from most latitudes on Earth can be challenging due to its location. Proxima Centauri is best seen from areas below the 27th parallel. As we now know, the red dwarf does not orbit alone. It is part of the Alpha Centauri system, along with Alpha Centauri A and Alpha Centauri B. In the summer of 2016, scientists used the radial velocity method to confirm the existence of the exoplanet Proxima b. Its spatial position relative to its host star gives rise to the assumption that liquid water could exist on the planet. Since Proxima b is the closest known exoplanet to Earth, it is a prime candidate for detailed investigation compared to other, more distant objects. The planet's mass is estimated to be between 1.2 and 3 Earth masses. Based on the luminosity of its host star, its spatial position, and its estimated albedo, scientists estimate the planet's average surface temperature to be about -38 degrees Fahrenheit. If Proxima b has an atmosphere, it could create a greenhouse effect, raising surface temperatures and potentially allowing for the existence of liquid water, a basic prerequisite for life as we know it. K2-72. In the Aquarius constellation, approximately 228 light-years from Earth, lies the planetary system K2-72. Alongside its red dwarf host star, this system includes 4 known planets. Among them, the confirmed exoplanet K2-72e has sparked particular interest. This celestial body, added to star maps via the transit method, has a radius about 0.86 times that of Earth. It experiences average surface temperatures of roughly 61 degrees Fahrenheit. K2-72e's orbital period is just 24 days, as it resides in the habitable zone of its planetary system. However, the planet's rotation is tidally locked. This means one side of the planet is perpetually exposed to its host star, while the opposite side remains in darkness. A narrow zone between these extremes could potentially harbor liquid water. Yet uncertainties remain. The planet's proximity to its star subjects it to much more intense radiation than Earth receives from the Sun. This heightened radiation might have caused all water on the planet's surface to evaporate, making it less hospitable for life. Enceladus. Finally, it's important to note that we don't need to venture into distant planetary systems to find celestial bodies with the potential for life. Even Saturn's moon Enceladus has been considered a strong candidate for hosting extraterrestrial life. At first glance, this possibility may seem improbable. Enceladus' surface is covered with a thick layer of ice, and its average surface temperature plunges to a frigid -328 degrees Fahrenheit. Despite these extreme conditions, scientists believe that life could exist beneath the moon's icy exterior. Beneath the frozen crust, Enceladus is thought to host a vast subterranean ocean of liquid water. Supporting this hypothesis are the numerous cryovolcanic formations that spew plumes of water vapor, ice particles, and other materials into space. These emissions contain intriguing chemical compounds, including methane. One possibility is that methane on Enceladus is being produced by microbial life in hydrothermal vents at the ocean floor, similar to the ecosystems found around Earth's deep-sea hydrothermal vents. However, alternative explanations, such as unknown geological or chemical processes, cannot yet be ruled out. As researchers continue to investigate this fascinating moon, the hope of discovering signs of microbial life remains alive. Enceladus exemplifies how even within our own solar system, celestial bodies can surprise us with their potential to harbor the ingredients for life. Don't forget to subscribe to our channel Insane of Curiosity for more fascinating content about the mysteries of the universe. Like and share this video with your friends and family to spread the excitement of discovery. Thanks for watching, and we'll see you soon in our next video.